Applications that will be hosted on the Kubernetes services will need some kind of a volume to store and retrieve the data. You can use a local storage or a fast SSD storage. At times, you may need the data, and in other instances, when pods are deleted because of low workload, the volumes may also get deleted. So, there are different scenarios for retaining your data and not retaining your data. Let's talk about the different use cases here and various core concepts like volumes, persistent volumes, storage classes, and persistent volume claims. Kubernetes treats your individual pods and containers as ephemeral. That means something that is disposable, something that's not permanent or is temporary in nature. With this approach, the applications will be using the data as necessary. The volumes will be represented to the container to store, retrieve, and persist data only for certain duration of time. With volumes, you can present Azure disks or Azure files to the Kubernetes cluster. Azure disks can be used to create a Kubernetes data disk resource. You can go ahead and create an Azure disk from the Azure portal and choose various options you have, including the premium storage, which is backed up by the high performance SSD, or choose a standard storage for regular HDDs. For most of the production and development workloads, you would use a premium storage. You can also use an Azure file, which is used to mount as a SMB 3.0 share by the Azure storage account to the pods. When you use Azure files, you can share the data across multiple nodes and pods. But there may be situations where you may want to retain the data for a longer period of time. That is, even if the pod goes offline or is deleted, you may want to retain the data. That is what a persistent volume is. A persistent volume is something that is existing even after the life cycle of a pod. What we spoke earlier was about volumes that will be defined and created as part of the pod life cycle only until the pod is deleted. Persistent volumes will exist beyond the lifetime of an individual pod. You can again continue to use Azure disks and files to provide that persistent volume. Let's try to understand a storage class. A storage class provides a way for an administrator to describe the classes of the storage they offer. We know that Kubernetes is open source and is used by several other providers, including Amazon and Google and Azure as well. So, different kinds of cloud providers provide different kinds of storage. In Azure, we would like to use Azure Files or Azure Disk for that matter. So, how would you present it to the Kubernetes cluster? It has to be written in the JSON format. So if you look at this particular code here, it is saying that the storage class is Azure file. You can also present it in the form of a disk as shown in this code. So if you'd like to present a disk or a file, you need to represent that in the form of a storage class. But what will happen if you do not present anything in the code? Well, there is a default option, and the default storage class will then be picked up. The default storage class will be Standard Azure Disk. Standard Azure Disk is backed up by HDDs. It is a cost-effective storage and is ideal way for dev and test workloads. But if you would like to get more performance, you would like to have an SSD-based high performance, then you have to define a managed premium storage class. So there are two kinds of storage classes that Azure Kubernetes Services offers. The default and the second one is managed premium storage class. Let's understand another aspect of volumes here. This is called as persistent volume claims. Now when you define storage, you need to define what is the minimum resources that the volume requires. What kind of access mode the volume should have. For example, do you want it like a read write once, or read only many, or read write many? What kind of storage class names would you like to give to it? These are called as metadata of the storage because you would like to define who the provider is. For example, is it picking up from NFS or is it Azure Disk? If you're using other cloud providers' disks, for example, Google or Amazon, then you may want to define, is it a GCE persistent disk or AWS Elastic Block Store? What is it? Capacity information about the persistent volume resources and the capacity is also defined. The persistent volume claims is also defined here. What is your reclaim policy? What it means is that what happens when corresponding volume is deleted? Would you like to retain it, delete it, or recycle it? These kind of attributes are defined in the persistent volume claim section.